Easy Physics and Mathematics. This is the solution to Igcse Physics Paper 3, Theory, February-March 2023. Question 1. Figure 1.1 shows two strips of staples. Each of the strips contains 40 staples. The width of one strip is 56 mm. There are 40 staples in the strip. Calculate the average width of one staple. So if there are 40 staples and then this width is 56 mm, then average width of one staple is going to be 56 mm divided by 40, which is 1.4 millimeter. So 1.4 millimeter, it will be very difficult to measure 1.4 accurately with the ruler, but measuring the multiple staple make it easier to carry out the measurement, so it reduces the uncertainty. So the width of one staple is 1.4 millimeter. A student wants to find the volume of one strip of 40 staples. The student has a measuring cylinder and a beaker of water as shown. So you have the strip of staple, you have the measuring cylinder, then you have water. So what will the student do? Basically describe how the student can determine the volume of one strip of staple. So what the student need to do is simple. He pour water into the measuring cylinder to partially fill to a level. Take note of the level of the water and record it as V1. Then submerge the staple inside the measuring cylinder, and then the volume rises to V2. Then the upthrust, that is the increase in volume, is equal to the volume of the staple that has been submerged. So the volume of the staple is going to be the difference in the volume rise, which is V2 take away V1. The staples are made from a block of metal. The mass of the block is 296 grams. The volume of the block is 33.2 cm cube. Calculate the density of the metal, include the units. So formula for density, stating the formula give you 1 mark, which is mass divided by volume. So we are given that is 296 over 33.2. that gives 8.92 gram per cm cube. So write that and then you state the unit. A student has a spring of length 14 cm. So we have the initial length of the spring 14 cm. Then she stretches the spring by adding different load to the spring. She measures the length of spring for each load. She plots a graph of her result. Figure 2.1 shows the graph of her result. So that is a result, the graph on the right hand side. Then using the graph, determine the length of the spring when the student add a load of 8 Newton to it. Add a load of 8 Newton. So from 8 Newton, trace the line until it meets the straight line graph. Then trace it to the vertical axis to know the length. That is, so with that, what will be the new length? So the new length is going to be 20 cm. So the load of 8 Newton will stretch the spring from 14 cm to 20 cm. So what is the extension? Extension is 20 take away 14. which is about 6 cm. Question 2, AII. Use the graph to determine the load added to the spring when the extension is 7 cm. Extension is 7 cm. So from 14, it extended for 7 cm extension. So add 7 to 14, that gives about 21. That will give a new length. So from that new length, trace it until it meets the graph, then trace it to the load. So what is that value? That gives 9.3 Newton. So that is the load that will produce the extension of 7 cm. Complete the sentence about effect of force. Choose a word from the box. So you have charge, mass, power, shape, and velocity. A load stretching a spring is an example of a force changing the size and the dash of the object. When this load was added to the spring, what altered in the spring is the shape. So the shape of the object. So the spring became longer. So the length was deformed. A clamp stand used in the experiment has a weight of 8.4 Newton. Calculate the mass of the stand. So from there, you know mass is equal to weight divided by strength of gravity. So M is equal to W over G. So that is 0.8775. So approximately that is 8.8 kg. So because expect to put your answer in two significant figures. Question 3 shows the distance time graph for a cyclist. The journey had two sections, section PQ and section QR. So you have section PQ from O to this point when distance time graph, okay, and then at this point from Q to R is not moving, so it's at rest. So how long was it resting? From 10 seconds to 30 seconds. So it rested for 20 seconds. So how long was it moving? It moved for 10 seconds. And how fast was it moving? So you divide that distance. Calculate the speed of the cyclist in section PQ. So how far did it travel in P? So you have that. It traveled 250 meters in 10 seconds. So you divide that. That is 25 meters per second. Describe the motion of the cyclic in section QR. The cyclic, I said, because it's not moving bit from 10 seconds to 30 seconds, the distance remained at 250. That is to show that it was stationary, it was not moving. The cyclic is at rest. The cyclist stopped moving. The second part of this question, question 3b, figure 3.2 show a bicycle fitted with wide tire and a bicycle fitted with narrow tire. The two bicycles have the same weight. People use bicycles fitted with wide tire to ride. So explain why people use bicycle fitted with wide tire to ride over soft ground. Use your idea about pressure. Right, thank God. So they say use the idea about pressure. So why? The question is to prevent sinking. So they ride over soft ground to prevent sinking. So if you want to use a bicycle that will not sink, wow. So why? Because pressure is equal to, use the idea about pressure to explain, pressure is equal to force divided by area. So the wider the area, if this area is bigger, that is the wider the area, the lower the pressure, because pressure is inversely proportional to area. So if you want high pressure, then the base area have to be small. So this tire with narrow tire will produce high pressure, which can easily sink on soft ground. Why this with wide tire we have low pressure, and then it can move over soft ground. So the wider the area, the lower the pressure. So which one is not good for moving over soft ground? The one with narrow tire, while the one with wide tire is good for moving over thick ground. Explain why people use bicycle fitted with wide tire to move. Wide tire have large contact area, so it produces less pressure on the ground. And then because it produces less pressure, the bicycle is not likely to sink into soft ground. And then the opposite is what will happen with the narrow tire. So narrow tire have small contact area, and they produce high pressure on the ground, and then this is the particles of gas moving inside the gas jar. You can see that the particles are moving randomly in different directions at high speed, and the particle collide with the wall of the container and bounce off. The collision of the particle with the wall of the container is what is responsible for the pressure of the gas. So the higher the rate of collision, the higher the pressure. So how do we make it to collide? So let's reduce the space and make the particle. So if you see, if we reduce the volume, the rate of collision increases. So you see the pressure is rising. So the pressure has risen. But if we reduce the rate of collision by increasing the pressure, by increasing the volume, you see that the pressure reduces 21 atmosphere. But if I increase it, so the pressure has gone to 58 atmosphere. All right. With that demonstration, say show some gas at room temperature in a cylinder with a piston that can move. The gas cannot escape from the cylinder, like in the animation I just showed to you. Describe the movement of the gas particle. So what did you see? The gas particle move freely with high speed randomly in all directions. Okay, for say that the particle move freely, you have one mark. Then to show that they move randomly, you have the second mark. Describe how the gas exerts pressure on the wall of the cylinder and piston. Collision of particle with the wall of the cylinder produce gas pressure. Question 5. This question is about work, energy stored, and energy transferred. 5.1, figure 5.1 show a boy pulling a toy trolley across the ground. Now, the horizontal force that is pulling it is 12 Newton, and he pulled it through the distance of 5 meters. Calculate the mechanical work done on the toy trolley by the force of 12 Newton. So this is a direct question. So mechanical work is equal to force multiplied by distance. So the force 12 Newton multiplied by the distance of 5 meters, that gives 60 Newton meter. Or the second unit of work done is joule, so 60 joule. Five 5.2 shows a candle burning. Describe the energy transfer taking place as a candle burn. Your answer should refer to the energy stored as well as transfer between the energy stores and energy transfer between the energy stores. So for example, inside the candle you have the store of chemical energy. Then when there is fire, there is burning, so it's converted to light energy. And then the more it burns, the candle become hot. So we have chemical energy stored in candle decreases because as it burns, it converted to light energy. And then the light energy, the longer the candle burns, the hotter the heat is used to produce this thermal energy. And then the energy is transferred by light wave, and then thermal energy stored of the surrounding increases. So these are just the three basic things that's happening here. Question 6 show how the displacement of transverse wave vary with time. So we have this in 0.4 seconds. We have the particle. So we have that. So if we have those particles, so the variation that is taking place. Alright, so if we look at it, determine the amplitude of the wave. What is the amplitude? The amplitude of the wave is the distance from the equilibrium point to the maximum displacement. So that is about 2 cm. Determine the frequency of the wave. Frequency is the time taken for the wave to make one complete oscillation. So the number of oscillations made in 1 second, that is the frequency. So if you look at it here, what is the period? The period of the wave is how long does the wave take to make one complete circle to go round. That is, you have 2, okay, 0.2 seconds is the period. So frequency is the reciprocal of period. So that gives 5 Hz. That is the frequency. Describe the motion of the particle in a transverse wave. So the particle vibrates at right angle to direction of motion. So you have the blue arrow is the direction of the motion, while the green arrow shows the direction of the motion, while the blue arrow shows the direction of the vibration of the particle. So it vibrates up and down. So that is the vibration. While the wave is traveling to the right, the particles are moving, vibrating up and down. Now, a wave has a frequency of this and the wavelength of 0.9 meter. Calculate the velocity of the wave. Velocity of the wave, frequency multiplied by wavelength. So multiply that out. It's a direct question. That is 360 meters per second. Question 7. The student take a book in front of a mirror. State 3 characteristics of the image of the book formed by the plane mirror. Number 1, the image is going to have the same size as the book. Then the distance of the book in front of the mirror is the same distance that the image is going to have behind the mirror. So because object distance is equal to image distance. Then the image of the book cannot be cast on a screen because the image is a visual image. So you have these 3 characteristics. And then the other one is the lateral inversion. So the book is going to have lateral inversion. The image of the book is going to have a lateral flip. Right hand flip to the left side. Visible light is one region of the electromagnetic spectrum. Another region is ultraviolet radiation. Give one use of ultraviolet radiation. First of all, let's just look at the electromagnetic spectrum. You have the purple. You have that is the frequency vary from radio wave. So this is radio wave, then microwave, infrared, visible spectrum, then you have ultraviolet, then you have X-ray, then gamma ray. As we are moving from the left to the right, the frequency increases. So let's look at that. So this mnemonic, you can just use G. That's the way I tell my students to remember it. So I think that can help you to remember the spectrum. So give one use of ultraviolet. So used to detect security marking on banknotes. So, or sterilize water to kill germs. So you have those two basic uses. Give one possible harmful effect of the excessive exposure to ultraviolet radiation: damage to surface cell, then causes skin cancer. Question 8. A student uses a dry cloth to rub a plastic rod. State how the plastic rod gains positive charge from friction between the cloth and the rod. So when you rub, the electron move from the rod to the cloth. Rod has more positive charge than negative charges. So that is why he becomes positively charged. Now, three balls P, Q, and R. If you see, P is repelling Q. That's to tell you, unlike like charge repel. So if P is positive, that means Q is positive. So that is there. And then you see that Q is attracted to R. So if P is positive, Q is positive, then Q will attract the opposite charge here, because unlike charge attracts. So R is going to be negative. So ball R is negatively charged, while ball Q is positively charged. The student connects P to earth with a copper wire. Charges from the earth flow in the copper wire to ball P. State the name of the electrically charged particle moving in the copper wire. Free electrons. Question 9. Show an electric kettle. The power input to the kettle is 1.5 kilowatts. The potential difference of the main supply to the kettle is 220 volts. Calculate the current in the kettle when it is switched on. So current is equal to power divided by potential difference, because power is equal to VI. So substituting that gives 6.81 ampere. Now the 1.5 kilowatt kettle is used for a total of 40 hours. The cost of 1 kilowatt hour of electric energy is 14 pennies. Calculate the cost of the energy used by the kettle in 4 hours. So what we need to do is calculate how many kilowatt hours are there. So you have the power multiplied by time multiplied by the cost. So we find that, so that will become 4 multiply that multiplied by the cost for 1 kilowatt hour, which is 14 pennies. That gives 80 by the cost for 1 kilowatt hour, which is 14 pennies. That gives 84 pennies. Question 9b. Show an overloaded extension lead. Now, this is the extension lead that is coming right. Now, the concept here is that you know that the appliances are connected to the electrical lead in parallel. So when this lead comes, so if you look at each of this, so this wire is, let's assume that is 2 ampere of energy is what is powering the gadget. Then the next one, 2 ampere, that is 6 ampere, that is 8 ampere, that is 10 amperes, that is 12 amperes, that is 14 ampere. So imagine that. So what's going to happen? So in the whole, you have 2 ampere multiplied by 8 extension gadgets connected to the same extension lead. That produce 16 ampere in the lead. But if the maximum current that the lead can hold is 12 ampere, so it's already overloaded. So overloaded, and then that is going to lead to the heating, and then this can lead to accident, fire accident. Explain the danger of connecting too many plugs to an extension lead. Large current flow in the extension lead. So I've just explained how the large current will be built up. Then large current can cause overheating of the extension wire and produce fire. So that is the danger. Question 10. Show 2 coils P and Q each in a circuit. The end of the coil are close but not touching. So we are going to look at, this is electromagnetic induction. Now, switch S is closed. So if I close this switch X, then current is going to flow in this coil P. And when current flow, because it's a solenoid, it's going to produce electromagnetic field. So what happens? When switch S is closed, current in coil B producing changing magnetic field in P. So that magnetic field that is produced in P, the flux is going to be induced and cut Q, and then that is going to induce current. Current will now flow without be detected by the galvanometer. So that is why the galvanometer. So the changing magnetic field in P creates magnetic field link that cut Q, which induce EMF or current in Q, and that is what is being detected by the galvanometer deflection. Describe the construction of a step-up transformer. You may draw a label diagram as part of your answer. 3 marks for this question. So this is a basic diagram for a step-up transformer. So the primary coil have lower number of coil, then the secondary coil have higher number of turns in the coil, and then both the primary and secondary connected by an iron coil. So that is the diagram you're expected to draw. Now, what is the explanation? A step-up transformer have 2 coils of copper wire wrapped around a link soft iron coil. Then the secondary coil has more turn than the turns on the primary coil. So you finish simple description. Question 11. Americium 241 is a radioactive nuclide. The nuclide notation for the nucleus is this. Now, this shows 241 is a nuclear number, which is the total number of protons and neutrons, while the 95 is the atomic number, which is the number of protons. So how many protons is in this nuclide? Is 95 protons. How many neutrons are there? So subtract 95 from 241 will give you the number of neutrons, which is 146 neutron. Then the nuclide has a half-life of 430 years. A radioactive source contains 12 milligrams of the nuclide. Calculate the mass of nuclei that remain in the source after 860 years. So to do that, you have to see how many half-life is in 860 years. So you start the mass at the beginning at 0 seconds is 12 milligrams. After the first half-life, so it will reduce by half. Then second half-life, they will reduce to half. So what is the mass that is remaining after two half-life? So you have this from 0 to 430 years, that is the first half-life. 430 years plus another 430 years will give 860 years, the second half-life. And then the total mass that will be remaining will be 3 grams. So what is the mass that have decayed after two half-life? Now you subtract 3 from 12 milligrams. So that will be 9 milligrams that have decayed. Question 12. State in order the name of 3 planets closest to the sun. Wow, so if you look at that, the name of the planet closest to the sun, okay, we have Mercury, Venus, and the Earth. Okay, if you look at that, you have MVE, MJS, UN. That is the 8th planet. So what are they? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now this is how I tell my students to remember it. My very excited mother just served us noodles. So you can use that to remember the order of the planets. My very excited mother just served us noodles. For my Mercury, very Venus, excited, Earth, Mom, Mars, Joss, Jupiter, Serve, Saturn, Earth, Uranus, Noodles, Neptune. So you can use that. Now define a light year. The distance traveled by light in vacuum space in 1 year. Okay, a Jupiter is 708. What do I call this now? 780,000 million meter away from the sun. Now the speed of the sun is 300 million meter per second. Calculate the time taken for light to travel from the sun to Jupiter. So we have what? Time is equal to distance divided by speed. So you can do that, which is simple, 2,600 seconds. Yeah. So with that, we've come to the end of this paper review. I'm wishing you good luck as you prepare for your exam. Subscribe to Super Easy Physics and Mathematics, because more of such past questions will be uploaded to help you prepare better for your examination. Like the video and share with your friends.
Subscribe and we will help you to easily upgrade your performance to an A+.
CPAM is the solution to better grades.